Ionic compounds are formed when metals and non-metals combine with ionic bonds. They exist in a giant ionic lattice structure, which is basically a 3D cubic structure where the positive and negative ions are held together by strong electrostatic forces of attraction between them. You can represent these structures using normal 3D diagrams where the spheres represent the ions, or ball and stick diagrams where the ionic bonds between the ions are represented with lines. There are 4 key properties of ionic compounds that you need to know about. The first is that they have high melting and boiling points, and this is due to the strong electrostatic forces of attraction between the oppositely charged ions, which need a large amount of energy to overcome. The second property of ionic compounds is that they're soluble in water, which means they dissolve in water and create a solution. The third property is that ionic compounds conduct electricity only when they're molten or aqueous. This just means when they're liquid or dissolved in water in a solution. When they're in these states, the ions in them are free to move, so they can carry a charge. So this basically means they can conduct electricity. When they're in a solid form, on the other hand, the ions are fixed and are not free to move. This means they can't carry a charge and therefore do not conduct electricity in this state. This is the final property. The structures of ionic compounds can be represented using different types of diagrams. Dot and cross diagrams are simple to draw and show electrons, however they do not show the size of the ions or their 3D arrangement. Ball and stick models, however, do show the 3D arrangement of ions, and they're very good at showing how the ions are arranged. However, they're difficult to draw and don't show the electrons in the compound. They also show gaps between the ions which don't actually exist in real life. 3D diagrams show all the ions in a more realistic 3D arrangement without the gaps between them. But these are even more difficult to draw accurately, and not all the ions are visible in them. You can use a 2D diagram, which is much more simple to draw, but these can be difficult to interpret for complex structures. There are 2 ways to determine the formula of an ionic compound. One is just by using the dot and cross diagram. So in this example, there are 2 lithiums and 1 oxygen ion. So this represents the formula Li2O. The other way to figure out the formula is by using the charges of the ions. This involves swapping the charges. So if we use calcium chloride as an example, you'd see that calcium has a charge of +2 because it's in group 2, and chlorine has a charge of -1 because it's in group 7. You swap the numbers and remove the charges. So this gives calcium a 1 and chlorine a 2. If you have a 1, you never write it down, so now you can join them to give the formula CaCl2. Okay, now let's try a quiz on this topic. See how many questions you can get right. If you liked that video and want to see more, remember to subscribe to Flash Revision Lab to get notified every time we release new content.